next thing. Let's get rid of only owner, because like to have a function that only owner call might be useful for like if there's funds there, or like you're trying to do some kind of like high level thing. But for like someone just interacting with a smart contract, you want to just allow anyone to do that. We can still use ownable, and we can still kind of like inherit the ownable and like transfer the ownership so that we still have access to the smart contract and we still own it, because we might want to use it later. But instead, let's do like a different require statement. Let's do require message dot value is equal to some kind of variable we're going to set. We'll set price, okay? And then otherwise we'll say not enough. Can't spell this, okay. Okay, so there's that. And then what we can do is set that variable. So we can say uint public price equals 0.001 ether. Okay, and you can see like it tells me exactly how much way is equal to ether, but you could define it as way there, or you could define it as ether. It's going to work either way, right? So we can set that, save it, and then we have to also, because now we have a function where we want to accept some value there, and we're going to check against the value that comes in that transaction. So now we want to make this payable, right? So let's do that. So now that it's payable, and we are requiring some value there, so our deploy was successful, then we can come back, and now we can see we get a new variable, right? We got this new variable for price. It's in way. So, you know, obviously if you're like building an app, you don't want your like user to have to like type in these crazy long amount of ways. So you want to like in your UI, you would kind of like do that calculation with like ethers, because ethers is part of the component. And we'll get to React in a little bit, and I'll kind of show you guys around what that looks like. But we'll see that our purpose now is here, like you can set a name, but you also have this new value for the value, right? You have to send some value. So if I come over here and say like foo like this, and I put in 0.00001, right, the wrong amount, you'll see there's like this little green button, which is kind of cool. It just does the math for you to like convert to way. So you just it's going to do time basically to the 10 to the 18th power, or times 10 to the 18th power, sorry, and it's going to convert it for you. So if I was to try to do that, it's going to tell me that not enough, right? I didn't add enough value. So you could just copy paste the price so we know exactly what it is, right? And then it lets me, right? So we're able to do this kind of like cool like vending machine, right? Where actually our contract now, you can see, is it has some value, right? It's got $1.29 in there. So you can start thinking of like your smart contract as like this way for people to be incentivized to interact with your function, and then it can store value. But there's a problem here. The problem is now the money is locked in the smart contract because we don't have a withdraw function. So the next thing you would do is probably do a withdraw function, right? And so we could do something like that. We could do function, withdraw, public, and then we say only owner for that one, right? Because we only want to set the owner, right? And then we can do something like we set a bool, success. Otherwise, we won't set a boolean. Equal message dot value dot call. Sorry. And then value equals, or value is, what is it? This dot address balance, I think. Let's see if that works. And I think I do this. I think that's right. Let's see if that works. I think if I wrote that right. Address dot this balance, yeah? That is? Address, no, address, and in the bracket you have to put it. Oh, here? Yeah. Like that? No, remove balance. Dot balance. Yeah, thank you. Remove extra point. Refer to the bracket. Thank you. See, not enough coffee. All right. Really? Like this? Anyways, but let's just keep going. But you get the idea. You would have, well, next you would have a function. We're not actually going to worry about that. Let's keep going though. So I want to show, let me reset real quick. I want to show a little bit of like the kind of React code so that you kind of can get a feel for like what that's like. Inside of the source directory, we have the app.jsx file. This is kind of, again, this is like, well, you have like your app.jsx is kind of like where you're going to like have like the main component. Sorry, earlier I said it was app.jsx. App.jsx is actually like the main component. It's also where you can change like your network, right? So if you want to deploy to a test net, eventually you'll also want to update your UI so that it reflects that. So you can just come in here, you could do something like type queryly, and it would update as well. Just save that. So we can save that. And then inside of the views directory, we have like the example UI, which I didn't get to yet, but I'll show you. And then there's the home JSX. So actually this is where in home JSX is where you would build your dApp inside of Scaffold-eth. And then there's also a subgraph support as well. So has anyone heard of the graph? All right, I'm sure you guys have heard. What's really cool is there's a built-in kind of installation of that runs in Docker. So the additional step is that you have to install and set up Docker on your machine. But once you spin up the graph, it's like a local graph node, and then you get access to the graph API, and then you can actually access the API data through like this kind of like graph IQL like internal kind of browser. And then you can kind of like toy around with like using the graph as opposed to using like events, because if the minute you start getting lots of events in your smart contract, it can get kind of clunky. And so the graph is a good solution. So I highly recommend too, if you guys are like looking at ways to optimize, the graph is a good as well. The hints is just like kind of going to walk you through and like explain to you like some of the stuff that I've been explaining to you, tells you where to go in certain things. So your front end is going to be here in app.jsx. Tells you like to explore the hooks, because there's inside of, let me go back to that real quick, inside of home app.jsx, you can see that there's a lot of inherited stuff already available to you. One of those is ETH hooks, which is also built by Austin Griffith and the Build Guild. And it's got a lot of components that allow you to like really just easily access your smart contract. And then the example UI has like kind of examples of how you would like do React. Like my crutch is React. I'm not really great with it. So like, this is great if you're like building something you can like kind of copy and paste. It's got like ENS support. Like it shows you what to do like an ENS example, how to like get your address, how to see balances, you know, how to do like just little buttons that allow you to call certain functions, right? So if I want to just set the purpose to cheers, I didn't set any value. But yeah, you get the idea. It's just kind of like example. There's also an instance of the mainnet DAI contract that's there as well if you're going to do anything with stable coins. We're going to go from there. Okay, so now that I've showed you kind of like a basic walkthrough of Scaffold-eth, make sure this deployed. We reset it. Okay, so I'm actually going to stop this one. Let's go here, and we're going to stop this one as well. And I've just got another tab basically open where I've kind of already done the same thing. Oh, this is like really hard to read. You guys see that okay? Ethereum CD challenge 0. So I'm in the challenge 0 directory. So basically what this is I told you earlier that there's different builds of Scaffold-eth. If you go to the GitHub and you go back to like the root of Scaffold-eth, you'll see there's two other kind of repositories. It can get a little confusing. There's Scaffold-eth, which has like a lot of like examples for like I said, NFTs, you know, different implementations of that stuff. The Scaffold-eth examples folder has some additional ones that might not be there. And then you have this challenges. So the challenges is basically everything that you do with speedrun Ethereum is available there. So the first step that you do for a challenge is you actually check out that repository. So the very first one you come to is the challenge, the simple NFT example. So we have access to it here, and I've already checked it out. And this is all available in speedrun Ethereum as well, but it's also in the README. I think it just pulls from there actually. So it's the same kind of setup. If you're going to do challenge 0, which I would highly recommend everyone here, as soon as you get to a stable internet, or if you can like wait through the yarn install and the git checkout. After you do that, like, everything is pretty much functional. So I've already done the checkout here. I've already done the yarn install. Let's just make sure. Done. Oh, and the other step is you do need to check out the right branch, because this root branch, it's a little confusing at first, is the master branch is just a basic README, and you have to actually check out this branch. So you'll clone the repository, and the extra step is that you'll check out this simple NFT example, which again, it tells you that here. So you just have to make sure you follow along. You can pretty much do this like in probably like 10 minutes. It's pretty easy. And then we're gonna kind of walk through a little bit right now. So I've already done that, did the install. So let's do the same thing. Let's do yarn chain. Let's do yarn start. Gotta close this one. Close. Oh, we keep that one open actually. Okay. All right. So while that loads, let me just come over here and do a yarn deploy. So now we're going to deploy this new instance, and let's grab the config file as well. So let's do atom dot. And let's take a look at what's different with this, basically. So let's see if it deployed successfully. It did, and React started. So let's look at the UI. So what do we got? Localhost 2000. And you'll see that we get like a whole new kind of experience, right? We have the your collectibles, and we have this like transfer function. So we can call a transfer. We can also upload to IPFS, like metadata. You can also download, and then we also have our debug contracts folder. So you'll notice the debug contracts is a lot more involved, and that's because we are inheriting the Open Zeppelin smart contract for ERC 721. So let's take a look at that real quick. So we go to contracts, your contract, and we see that we have just a different version of Solidity, essentially. We're importing all of the ERC 721 standard stuff. We inherit that stuff, and then we have like these overrides we're doing on minting, and it gets a little more complicated, but really all we're doing is just setting the URL for the NFTs, and then we're minting NFTs here and keeping track of the counter for the index of those. And there's a bunch of stuff here. There's like, we're just setting the token URI, and we also have the ability to like burn NFTs as well. So this is already written for you, so you have this starting point, and then you can change the name of your NFT to whatever you want. So especially for hackathons, it's great because you can just, if you're doing an NFT project, you just use this as your starting point, right? And then we can come over here, and just with the button, we can see how easy it is to mint an NFT. Oh, we need to grab some funds. And let's just start minting some NFTs. Mints. Oh no, that's not good. It's probably my internet connection because it's trying to like use IPFS. Yeah, it's trying to do IPFS. So this might not actually work. Sorry, guys. But normally what you would do is you'd be able to mint an NFT, because what happens is there's this like kind of like JSON file that's already created for you. I don't know exactly where it is. Let's see. It's in React. Source. It might actually be in one of the, let's see. Right. Source. Trying to remember where it is. Index, no, let's see, object. So yeah, there we go. So there's this JSON structure kind of already created for the NFTs. So what you can do is you can come in here and edit the URLs. So all these NFTs are actually created by Austin Griffith. They're like little paintings that he did on Nifty Ink. So if you guys aren't familiar with Nifty Ink, you should check that out. You can like draw on there and like basically create an NFT on there. So he has all those on his website. So these are just like NFTs, and you can see here how we just like have this JSON file. You can customize it with the name, description, the URL. Maybe if you want to add traits to those NFTs, you can do that. And then what this mint button here is doing, if the internet connection would work, is just basically grabbing that file and then creating an NFT, right? And then if we look at the actual code, again, for the actual smart contract, you can kind of get in and kind of like learn exactly how ERC 721 works and kind of explore. So if you're just getting started, again, I think what I would recommend is, obviously check out the repository, toy around just with like kind of copy and pasting stuff from Solidity by example into your smart contract. If you get more, as you get more kind of knowledgeable on understanding Solidity and understanding, how stuff works, then start going through the speedrun challenges. The simple NFT one is really, really easy. Again, it takes like 10 minutes. But as you get further down here, like they get a little more complicated, and you kind of have to start like even like the dice game, you have to figure out a way to like game the randomness of the smart contract and kind of like hack it a little bit. And then as you get here, like when you get to build a DEX, I mean, you're literally like building a DEX on your own. Like it's really, really difficult. So as you get down, you'll find that pretty much after you get through all of speedrun Ethereum, you'll be pretty much ready and set to go and get hired as a Solidity developer, right? That's the goal. And you can be part of the build guild. So yeah, so that's my demo. I'd like to just see if you guys had any questions or if anyone wanted to. Yep.
Do you have like a TypeScript template?
Yeah, so there's a TypeScript build of Scaffold-eth that you can get. You just can come here to Scaffold-eth, and I believe it's, let's see here. So Scaffold-eth. And then you can do a search for TypeScript. There it is. So it's a Next.js TypeScript implementation, and it is a lot faster actually. It's really fast with Next.js. So if you're good at TypeScript, that's definitely what I would recommend. Yeah. Yep. Okay, good question. Yeah. So the question was, what's the difference between storing NFTs on IPFS versus Arweave? IPFS is good if you're like paying for like pinning service of like your assets or if you're running like your own IPFS node and you can kind of guarantee uptime. But obviously the benefit for something like Arweave, and there's like another decentralized protocol where you can like pay up front for your storage. They use just a different kind of like decentralized algorithm. IPFS is all hash based, and it's all based on like the hash being like distributed across the IPFS cluster, but there always has to be one node that has the original kind of hashes. Otherwise, it's not going to get properly, it won't be available. And so that's why you see sometimes with like some NFT projects where you just don't see the image anymore. It's because they've launched this thing with IPFS and then they haven't pinned it properly and it's pretty much gone. And then you have to like update the URI in the NFT, and that usually doesn't happen because you have to pay for gas for that. So yeah, something like Arweave is good. Or again, if you're using something like Pinata or some other like IPFS pinning, that's advised. Yeah. Yep.
So the first one is, what was the name of the library used for split terminal?
Oh, Tmux. Yeah. So the question was, what do I use for my my terminal? So this is Tmux. Yeah, it's really great. And you can kind of just like, you can create sessions, you can store your sessions. It's really useful. Tmux. Another question?
Yeah. Your recommended learning path to get started on the UI, kind of framework, then maybe do the node, like when you're ready, kind of to ship on maintenance.
Yeah. Yeah, I would have totally deployed, if the internet connection wasn't so great, my next plan was to deploy to a test net and then eventually to a mainnet. There's some things you need to do. So the question was basically like, for the UI, I think it's a two-part question, learning the UI components for like React and stuff like that. There's a lot of like traditional like React kind of stuff you can do. I don't really personally have a feeling because I'm not a React expert. Maybe someone else here does. But I would just kind of look at like React like introductory courses, because if you just get a basic understanding, like I said, most of the React stuff's already written and you can kind of copy paste and stuff like that. But as far as for the second question, if you're going to push your app to production or even to a testnet, you probably want to get your own instance of the Infura key. So we use Infura. So you want to generate your own Infura key and put that in before you launch to mainnet. That's one of the things we ask, because otherwise our API key gets bombarded. And then you also want to set up an Etherscan API key as well, so you can verify your smart contract. And then as far as like publishing to, like a mainnet, I would just consider like abstracting away as much of the Scaffold-eth stuff as you can, pulling it out, because you want your app to look right, polished. But there's a lot of cool apps out there that are actually still using all the little components and stuff like that too, as well. I didn't really get into it, but let me actually real quick, now that you say that, I do want to show one thing. If you're going to deploy to, if you're going to deploy to a testnet, you're going to want to use a Yarn you're going to use a deployer account. You're not going to want to use the hard hat account because everyone's private key in the hard hat is the same, I think. So you'll want to do a yarn run generate. So what that's going to do is it's going to generate a mnemonic, and it's going to store it in your base directory for Scaffold-eth. We can see it. It's right here, somewhere here. There it is, mnemonic.txt. I think in the newest version of Scaffold-eth, it's actually the public address.txt, so it's whatever the public address is. But I'm not going to click on it because it's the password there. But basically, it's going to use that special mnemonic as the deployer account so that there's no chance that someone can gain access to your smart contract. And then what you can do is you can do yarn account. And if you're going to deploy to a test net, what yarn account's going to do is going to give you the QR code for that account. And then what I do is I just use a Punk wallet on my phone, punkwallet.io. It's a way for you to like create a like kind of a little like toy wallet, and I just have it as like an icon on my desktop here on my phone. And I'll show it real quick. And then I just scan that that QR code and send my funds through this little camera reader. So punkwallet.io. And then at that point, if you're deploying to a testnet, you'll have testnet funds that you can transfer easily just by scanning that. And then obviously, if you want to deploy to mainnet, you need to do the same thing. You got to put some deployer funds on there. It's not working because of the internet, but normally what it would be doing right now is it would go through all the networks and tell you what your balance is. So you could send some funds and then run it again, right? And then see that your balance has been updated. And then you can do a yarn, So normally you do a yarn deploy. It's just using whatever hard hat is using for the deployment. So inside the hard hat config, so if we go to hard hat, trying to see where the hard hat config is. Oh, there it is. So inside the hard hat config, you can see it's configured as localhost. So if you were deploying to like Goerli, you could just type Goerli right there. Or you can just do, I think it's yarn deploy -- network Goerli, I think, that. And it would try to deploy to Goerli. Okay, so it's either or. You can just update it in the hard hat config, or you can just do a manual command there. So hopefully that answered your question. Sorry, it was a long-winded answer, but I just realized that I forgot to explain that, so that's useful. All right, what other questions you guys got? Yep. Yeah, there's actually a website. If my internet worked, I would tell you what it was. There's Juicebox, I think it's called, is like a kind of like a grants application that was all built on Scaffold-eth. Nifty Inc. was built on Scaffold-eth. Punk Wallet was built on Scaffold-eth. So there's a lot of like people actually using Scaffold-eth in production. You had a question? Yep, that's a great question. Thank you. And I didn't get to that either. So the test folder. The question was, there was a test folder here, and we can see we have this my test. So most of the builds come with a associated test file, so that when you deploy it, you can run a test. This test is actually part of the speedrun Ethereum. This test has to pass before you can get your thing approved. And you can write these, it's basically hard hat chai tests. So you can write it in JavaScript and you can test against, and definitely that's advised. And to do that, you just run yarn test, right? Like this. And it's going to fail because of the internet connection. Well, maybe it didn't. Oh, that's good. Okay. So we can see here that we did a challenge 0, simple NFT, and it worked, and it was deployed. And then if you start building your smart contract, you can start modifying your test, right, as you go. Good question. Yep. Good question. So the question was, can you use Foundry instead of hard hat? There is a Foundry build. So I think earlier, if you come over here and you do a search, there should be a Foundry version. Yep, right here. So when I first got in here, I was on the Foundry version. I think it's rather new. I don't know how 100% functional it is, but I think it's been tested and I think it's working. Yep. Good question. Yeah. Another question. I saw another hand somewhere. Awesome. Thank you guys so much for coming, and let me know if you need anything. I'll be around. So thank you. Dale, tranquilo. Tranquilo, ahí lleva.
Thank you.
Yeah.
That was awesome.
Yeah. Nice to meet you. What's your name?
Nice to meet you too. Mike.
Mike. Cool. Kevin. Is that useful?
Sydney for you?
He's not. Yeah. He just had a baby, so he's taking it easy. Yeah.
Yeah.
Yeah. He wanted to be super fun, but he couldn't make it. But, thank you so much.
Igual creo que ahorita sigue igual.
La pila está por ahí.
¿Las qué? ¿La pila? ¿Baterías? ¿Necesitas? Ah, ok. Hombre, no me acuerdo de ahí. Computadores no eléctricos. Necesito para no sé, pero me ayudan. Ah, bueno, corta la acá. ¿Acá ya la cortaste? No. ¿Toca cortarla?
Sí.
¿Listo? ¿También? ¿Lo mismo? Sí, sí,
Para
sí,
que
sí,
queden
te están
archivos
diciendo allá,
separados.
hazlo. Y pues acá ya,
Acá ya cortaste, iniciaste, ya está corriendo de cero.
sí, ya está corriendo atrás de ese lado.
Ahí le está llegando música, ¿tú sabes?
Sí, ahí está oscilando la música. Ah, espera, que llegue y no, pues se instala. Sí, ya veramos. Sí, si quiere usted, si quiere hágale. Ahorita hágale usted. ¿Tiene hambrecita? También, pero ya, ya va tarde, ya. Ah, no, es a las 30. Sí, esos manes no van a hacer presentación desde acá, van a hacerla desde allá todos, desde la imagen. Me lo huelía. Sí, esa presentación. Exactamente.
Hey, great. Yeah. Nick in the left or right? On the left. Okay, perfect. Wherever. Have a click or on the back? Well, excuse me. No,
И- Sorry?
Configuration for the screen.
Yeah, no, I think we need to update it.
Right? No problem with that.
No, sorry, what you're saying?
For this crop.
Yeah, this crop.
It's so important. Oh, maybe not so much.
Okay, let me see. Okay. Oh, no, it's all right. Oh, sorry, test. Wow, now we know it works. Okay. So how do I put it on, or you put it on the mic?
What?
The mic, who puts it on? The microphone.
Okay. I control the.
You control it. All right. Okay. Good. No, we're good.
Check. Okay. I have to.
Yeah. Okay. Good. All right. Thank you, man.
You
What?
don't need
No audio.
Dile que punto comenzamos, Bota, punto comenzamos, dile. En punto comenzamos, 1:30.
Yeah.
Para poder auxiliar y si no dejar el auxiliar en feita porque no está saliendo por auxiliar. Entonces voy a hacerle pausa. Pero todavía no es. Sí.
Спасибо. Мне кажется, народу будет не особо много. В принципе, меня радует. Все забили. Я говорю, все забили. На самом деле, посмотрел это время, оно, как бы, вот правильно сказал, популярное, но куча других людей выступает на большой сцене и прочее. И получается, ты с ними всеми соревнуешься. Вот. Да.
Но здесь как бы, кроме тогда церемонии, что любое время оно послушать.
Нет. Да, не, время хорошее, я говорю, но все равно. А еще сказали, что было у них типа 500 заявок на спикеров вот, на эту конференцию. И это самый большой Devcon за всю историю Devcon'ов. Bear Market. Тут, кстати, 6 этажей. Ты видела, в подвале сделали хакер-хаус на парковке у них? Нет? Потом сходим с тобой.
Ну, я не выходила с отступлением этого вообще как-то. Прикольно у них специализация, типа, такой голубистый, это...
Да, очень много с Латинской Америкой связано, там, инсталляции всякие, там, В общем,
Да,
растения и прочее.
делала. Ну, интересно, для воркшопа разных этапов.
Типа круглые столы, что спиной стоишь, не видишь? Ну да.
Ну, я поняла, почему, потому что у них некоторых там локаций есть, где они делятся на группы и все-таки дискутируют. Я сначала в другую группу зашла. Ну, смотри, народ успевает.
Да, да.
Всем мне сказать,
Девушек много сидит там в Девконе. Да. Нормально. Я не знаю, я понял, что самое сложное это в жизни получить удовольствие от всего происходящего. Не так сложно все сделать, как получить удовольствие. Ничего, сейчас типа проведу воркшоп и все. И можно чилить. Спасибо. Ты тоже. Как в итоге билет добыла?
Ну, так как и запланировано, но они спустились, сегодня не тот билет пришла, это по юзеру уже. И вообще полную стоимость хотели.
Кто, Зириан?
Да.
Ну, ты с ними договорилась, что ли? Классно.
В итоге они спустились мне и дали нормальный билет, и 2 раза выдали.
Ну, до 300 баксов получается, да? Хорошо. Няу. Oh, wow. Nice. Nice. Как пришел. Тест. Buenas tardes, everyone. My name is Igor Yovoy. I'm a Solidity developer, CEO founder, and previously I worked at Open Zeppelin and co-founded a DeFi startup called Babylon Finance. Today I'm excited to present you a workshop titled Unlimited Size Contracts. Before we jump into action, you might want to download a GitHub repo for this workshop. Either use the QR code or just Google GitHub YOV-IO workshop and you'll get it. We also will need a Foundry for this workshop. If you have it, great. If you don't have it, just install it using the link in the slide. And then run 2 commands, Foundry up and Forge build. I know internet is pretty bad here, and so for some reason you can't download it and install it. Don't worry, the repository will stay up and you have access to it, and I'll post the slides tomorrow. And I'll be doing some live demos so you can just watch and get the idea what's going on. Let's jump right into it. All right. Who has ever deployed here and written a smart contract? Please raise your hand. Yes, Solidity developers. Okay, who has ever run into the issue of a contract size limit here? Please raise your hand. Wow, it's way more problem than I thought. So yeah, this picture, it illustrates my personal pain. While working at Devcon Finance, we pretty quickly ran at the issue of a contract size limit. And it's not easy issue to address. And it causes us a lot of pain. And one fellow developer I know in Solidity space called this limitation, I quote, bane of my existence. So this is how big this problem is. And we are going to tackle it today. So there is a few solutions for this. Well, you can reduce bytecode size using various techniques. And essentially, it's like alternative sport to guess golfing. I call it bytecode golfing. I certainly do not recommend it because it's like a diminishing return sport. With each optimization, you have like less and less space left for each new function. And it even may compromise the security of your project. So I would be wary of using this technique. And I suggest to try to design your architecture from day zero in the way it supports your contracts to be unlimited size. Other solutions are external libraries, static precompiled router, and a dynamic router. We'll cover them in this workshop and hopefully have some time for questions and discussions. All right, we're going to use a simple contract as a baseline contract for this workshop. It's called a counter. It has a few functions. A set function, which sets a int variable to a new value, a get functions, which retrieves this variable, and finally a const functions, which just returns a constant. These are good functions for a baseline contract because they essentially utilize one sload operation, one store operation, and returning the constant value. And these examples are quite well spread in real smart contracts. All right, let's jump into the code. Here we have our counter contract. Again, I'm not going to spend any time on this. It's pretty basic. What is important about it, it's rather small. So if you look at the bytecode size, you can see it's under 1 kilobyte, which is great, and we have a lot of space left. But let's say a product team says, oh, actually, we need to implement this new call feature called quote, a function. And a quote function is a function which returns just like big string, which takes all the space. And then if you look at this big modular, it like takes almost all the space in the contract with few left. And if we try to implement it in very naive way using Solidity inheritance, so we just, okay, so the counter, the big modular, like done, job done. And then we discover that no, big counter is over the size of the limit. We can't deploy it. There's nothing can be done. It can't be optimized. So how we can solve it? The first solution is external libraries. External libraries is a feature of a Solidity. So how it works is that in your contract, in your methods, you just call a library instead of implementing it in the contract. In this case, we have two libraries. One is called storage lib, which contains our original counter methods such as set, get, const. And finally, we have a quote lib, which contains the only quote method, which contains this big string. And if you look at the implementation details, the catch here is that you need to pass this parameter, which is canonically called self and has a storage type. And this, like a special syntax in Solidity, allows you to modify storage in external contract. And essentially, external libraries in Solidity is just abstraction layer over delegate call. And that's basically it. There is not much to this. And if we go back to our presentation, we can quickly sum up all the ups and downs with approach. So the good part about it, it comes with some security guarantees by Solidity. The main important one is the library can't call self-destruct, so library can't destroy your smart contract, which is important, because it's not the case if you use delegate code directly, essentially proxies, where if a proxy contract calls self-destruct, your contract is done. It's somewhat easy to add one more leap. You can always introduce one more leap, and it's gas efficient to a degree, but a bit later on this. And the main downsides of this is that it's not truly infinite, because to add one more function, you need like external wrapper function, which stack up quite quickly. And eventually you will run out of space in your surface contract. And it doesn't matter how many leaps you can write more, there will be just no more space. And the final downside, maybe for some projects, external libraries can't be used, can't support upgradable contracts. So once you deploy your external libraries, it's like set in stone and you can't change it. Okay, the next approach is a static precompiled router. This work was pioneered by Alejandro Santander from Synthetics. He also previously worked at OpenZeppelin, and he is known as a Firnaut on Twitter. And if you look at, if you want to take a look at production-ready, stable code, I suggest you check out Hard Router package at the Synthetics repo. And what we are going to take a look at a simplified example. So the idea for the static router is pretty simple. It's a smart contract which has no external functions, and it only has a fallback and receive functions. And what it does, it calls a forward function inside both of them. And the forward function consists of two parts. The lookup part for the implementation address, and the assembly part for delegate call. I'm not going to spend time on this. I'm just going to say this is like a canonical implementation of a proxy delegate call in assembly, which is used by all the proxies. And what it does, it basically sends your function call to whatever the implementation contract is, and then returns its results. And the interesting part is here. So in Solidity, each function has a signature. And as you can see here, we have a switch for a signature method. And based on the signature of a called function, we pick up an implementation address, which is later used for delegate call. And as you can see here, we have 4 functions registered for a counter modular, which is a get, set, const, and 1 function registered for a quote modular, because it's like so big. And based on function signature, we do pick up a right implementation address and then use it for delegate call. And again, if you go to our contract sizes, why it works, because these are 3 separate contracts. We have a big modular which is within the limits. Then we have counter modular, which is also within the limits. And finally, static router itself is pretty small because it just with 1 function. Though the more functions you have, the more its byte size grows, because you have to add each function here as a new line, though it grows way less than external libraries example. And if we go back to slides, we can see what are the benefits of using it. It's extremely gas efficient. Why? Because it's all precompiled in bytecode, so you don't need to waste any expensive operations, SHS load on the router, so you don't, your different modules do not, your different modules do not write to the same storage. And then finally, development and maintenance overhead can be tricky, because you need to pre-compute all these signatures and addresses upfront, and you don't want to do it by hand, which is, I recommend check out again Hard Router. They built a plugin which does that for you. Well, this second approach, how you can achieve infinite size and compare to libraries, it's like better in the way which gives you like more control using like assembly and low-level language features. The next idea is iteration on a static router. It's not necessarily better, it's just a different approach. It depends on your project. I call it dynamic router. If you're interested in product level battle tested implementation of this idea, I highly recommend you to check out EAP 2535 by Nick Mudge. This EAP covers far more things than just unlimited contract size, but one thing it certainly does achieve is unlimited contract size through a dynamic router. I've written a simplified example of this dynamic router, so let's get to it so we can see how it works. It's quite similar to a static router in the same way it has a fallback receive functions, which just forward every function call to our forward function. But the difference comes in this line. If in a static router function, we have a switch case, which just goes, oh, have this, for this signature, I have this address. In a dynamic router, we are using a smart contract storage mapping, which is called modulus. And as you can see here, we pick up an implementation address using a message signature. And then the rest of the implementation function is the same. We just provide this implementation to delegate call, and essentially it works in the same way. The essential difference between static router and dynamic is the static router has all the signatures and all the implementations addresses hard-coded in its bytecode, where dynamic router use mapping on the storage of a smart contract to track them. And that adds pluses and minuses to this approach. So the pluses is once you deploy your dynamic router, you can add more modulus, even it's already deployed, or you can like fix bugs by updating it. Here I have this function update modulus, and it's also pretty straightforward. As you can see, we just iterate and add selectors to implementations. The downside of this approach is you have to manage access rights. You can't allow anyone to update functions of your router. That would be disastrous, a critical issue in security terms. And there are different ways to use it. You can use OpenZeppelin access roles or some like other techniques, but that's like out of the scope of this workshop. But you just have to keep this in mind. And if we go back to presentation, dynamic router is the first router which is truly infinite, because all the mappings between function signatures and implementations are inside the storage, which is, as we all know, very big in Solidity. Then you can literally add infinite amount of functions to this router. So it's very good for a complex system which would require upgrades and have like long expected lifetime. Then another option, another plus I just mentioned, it can be updated anytime. Well, I mean, it can be a minus if you're getting hacked, but generally it's a plus. Has no external functions. So the main downside of this is it's like gas expensive. This function is essentially here is reading a storage which is extra S load, which is about 2,000 gas, and the sad part, you have to pay it for every contract call. And then another downside is you have to manage access rights, who can update this router. If you want to build a truly unstoppable contract, maybe you don't want to have any upgrades. And there can be many solutions like governments and multisig, but you eventually have to figure it out for yourself. And these are the three main approaches which you can use to tackle infinite size contracts. And then what's like important, what's the difference between infinite size contracts and normal contracts in this approach? It comes down to a gas overheads. Essentially, here in this table, we are comparing our base contract with three approaches in terms of gas. And why gas is important, like a short story. When was like a bull run and gas prices were high, we were seeing the function calls for the users in the price ranges of $100, $200, and even $300 for some projects. And a lot of these gas costs were coming from using proxies, because proxies has a gas overhead at each function call. And if you really have a complex DeFi system where protocols call each other and they are all proxies, this amount of overhead stacks pretty heavily, even within your own protocol. And it's like important to keep an eye on these gas overhead costs. So let's dig down a bit in these numbers. The first base contract are the numbers for our base calls, so it's like no dedicate code involved. And then if you look at the base call for a constant call, it just returns a number. It's like very small. And the first number in red is just what's the overhead and gas, and the second number in red is in percentage. And you can see for like a simple return call of a constant value, the overhead is actually around 2000%, which is like insane. And you may say, oh, it's not practical, to return a constant value, but you'll be far from the truth, because the famous ERC20 token has a function called decimals, which returns how many decimals a token has. And you have to call this function if you're a DeFi developer, because in order to handle ERC20 token, you have to know how many decimals this token have. And one of the most common ERC20 tokens, like USDC, they are proxied contracts. So every time you call decimals, you're overpaying roughly 2000% or probably more. But anyway, let's take a high-level look at these approaches. So as you can see, indeed, static router is the most gas-efficient approach. So if you have to build a gas-efficient infinite contract and you know what kind of functions you're going to have and don't plan to upgrade, then it's like a great solution. And then dynamic router is more expensive, even more expensive than external library. The reason I wouldn't recommend external library, as you can see, it has unusually high overhead for quote, more than double than it should. And I think it has something to do with how Solidity pass with like big amounts of data. But I haven't dipped the bytecode yet, but just be wary if using external libraries and you pass or return big amounts of data, then your gas expenses may surprise you. And to take a look at this, what would be the high-level conclusions of this overview is that your gas overhead obviously is more significant for functions which are low in gas. So essentially, if your function has only a single S load, then you would pay a lot of gas. So what it means in practical terms, which I also encountered, is that if you need to build a function which returns some like data around your protocol smart contract, you may want to bulk them, all this data in one function call, so you don't need to call five functions in a row, because you would pay a gas overhead on each call. Essentially, batching view functions might be a good idea. Then, again, the bigger the baseline, as the gas is so important, I spent some time thinking and trying to figure out a trick how we can improve this. And I came up with a solution which we use successfully in production to reduce the gas cost of our contracts. I never found anyone using it somewhere on the internet or on GitHub. That is why I had to coin the term for this approach. So I'm calling it like loaded router. And so the approach is pretty simple. Because like if we go back to a static router, so the static router in our case, it doesn't take much space. And even if it grows, there's still a lot of space left. And what you can do essentially is, again, using Solidity inheritance, you can inherit some functions of your contract to a static router. which allows them to be as gas efficient as the contract itself, because it's essentially a contract itself. So in the other ways, if there is some space in terms of bytecode size left in your static router, you can put the functions there which either people use the most in your system, or the functions which has the highest gas overhead, like calling decimals. And this allows you to save quite a bit of gas, because just to give a better explanation of this, if you combine static router with a counter modular, we don't get to this forward function, because static router now is counter modular. And that results in a quite significant gas savings. And the same approach can be applied to dynamic router. Just gonna show you the code, but it's like pretty straightforward. You again can inherit counter modeling, but here this is the catch with a dynamic router, because in dynamic router we can update implementations of a function. If you place a function like get a set on the router itself, you will never be able to update it. So that is why it's like rather risky, and you should be very mindful which functions you put on dynamic router, because you don't want to be in a situation where a critical bug is found in the function and you can't update it, and it's just like a terrible situation to be in. And with this approach, we can crunch some gas numbers. So now here we're using routers themselves as a baseline, and then their loaded version essentially as improvement. And as you would expect, because we move a constant function from sitting behind the delegate call back on the router, it results either to 95% improvement or 97% improvement for a constant function. It results around 54 or 68% improvement for a get function, which is a single S load. And a single S load function is not that uncommon as you might think, because, for example, ERC20 balance of function is just a single S load. And again, this function is called a lot, and I don't really expect it to be changed. And then finally, for a single S store operation, the savings amount is about 11 or 18%, so it's like not that much, but like still sizable. And what you like looking at these numbers, my suggestion would be is to move low gas function on the router if they use a lot, so this is the most best saving, or just the functions you expect to be user-facing. So the functions people will use the most, again, as a transfer function, a deposit, or withdraw, or claim revert. And then finally, the pure functions, which is just a constant, have the biggest impact on this. And just to give this some practical meaning, let's take a look at the two most common contracts, essentially ERC20 token and ERC721, which is an NFT. We can see surprisingly many functions of ERC20 token, such as name and symbol and decimals. In most implementations, they really return a constant. You know, just like name is like my grade token, symbol is like 3 letters, and decimal is like 18 number, right? And in most projects, really, these functions will never change. And literally, if you write in ERC20 token, which has decimal functions which will return different values, I might have a problem with you. Please let me know. And even going back, even going later, so total supply, many ERC20 tokens has a fixed total supply, right? So there is, again, no reason for this function to be upgradable or to be sitting behind the delegate call. And then things get tricky, so I can see how transfer allowance or proof can be changed in the future, maybe standards changed, but it's like up to every developer. You have to make call on yourself whenever your project will encounter these issues in the future or not. And The same logic more or less applies to ERC 721. But these are just two common contracts. I really wanted to show on them kind of logic I would follow if I would build a complex system where I would just sit down and look at my contracts and look at which methods are not going to change for sure, and which are like safe to put on the router itself to save the gas, and which makes the most sense. Because, for example, at Babylon Finance, we had this like admin module which had like a lot of admin functions, but it's pretty much only us or governance we're calling them. So we really didn't care about the gas cost of this. So I was like confident just like putting them behind the digit call and being upgradable. And let's jump back to the code. So here you would see once we put these functions on our routers, they do grow in size. So a loaded static router is slightly bigger than just a static router. That's because we merged all these functions on this contract, and eventually you hit the size of how many functions you can put on your router, which we did, and that is why you also should be like mindful that you have to put the functions on the router, which like your absolute top priority in terms of gas. So if it's like questionable, don't do it. And the same applies to dynamic router, so it's higher. But to repeat, my security concern once again, dynamic router is different from static router in the sense that if you put a function on the router itself, then it can be upgraded later, and you should be like super careful doing this. The code, the repo is already public, and it has all these examples as well as the test, which which actually makes sure that all we discussed is worked. So here you can see that creating static router is simple because it has everything encoded in it. While to create a dynamic router, we need to build all these modules. So we need to dynamically fetch all the selectors for the methods. And then we create a module definition, which is an array of selectors binded to a certain implementation. And finally, we can use with modules to initialize our dynamic router with update modules. And this is the same way you can update existing functions or add new even after the deployment. And here we have tests to make sure that all these functions work. And if you will be checking out this repo later, you can run the following command, test gas report, to see all the gas numbers we just looked. And speaking of these gas numbers, these numbers are produced on 0.8 solidity compiler with optimization set on, and about 200 optimizations run on. Let's get back to our presentation. And that will be it. Thank you for your time. I hope you find it useful. I hope you built unlimited contracts successfully and never experienced the pain I did. Please follow my Twitter. I do post development stuff there. And I would be honored if there is any questions or discussions. Yes.
So the dynamic router, the loaded router, whether it's dynamic or static, it inherits from the counter module and then from either dynamic router or static router. Because the counter has all the functions except for quote, those function selectors will match to the functions on counter module and will never hit the switch statement on the static or the rest. If you were really doing this though, would you not, you wouldn't have the dynamic module with the same functions defined as modules that would be hit, and they would just be superseded by other function selectors, because you would leave those off.
Yeah.
Just for our example, though.
Yeah, I can tell you the following workshop. Great. Yeah, I didn't do it in my repo because I didn't want to just produce like more code and to get in this optimization game because yes, it's like exactly correct. So if you're making your router loaded, then the functions you put in the router yourself, you remove them either from the static part of the router or you never put them on the storage of a dynamic router because why do you need the same function twice? Yes. Anyone else? Yes.
So we should have techniques to avoid the limits. Do you have tools that allow us to see where we're actually
The space, yeah. I mean, both Hardhat and the Forge allow you to run different commands. So for Forge, you can run Forge build sizes, and it just shows you.
don't have a clear fragmentation before, but like, okay, where this is there any tool that actually
Sorry, you mean the byte size?
Yeah.
Well, you can have as many modules as you want for either dynamic or static router, but each of them is kept to the same size, 24 kilobytes, because it's still smart contract.
So before we run into optimizing like is there a tool that exists to help us see where our contract is staged?
Oh, yeah, it's a good question. Yeah, so what I did in our times is that maybe it's like wrong, but it's like dirty hack. I would just like delete everything inside the function and I see how much it drops. But it's fast and it works. I don't know, maybe with some automation right now, but that's the truth. Okay, anyone else? I saw some hands. Yeah. Yeah, I mean, it's like there's only one compiler right now, and I mean, I'm grateful for features we have, so I'm not gonna go in these directions. Okay, anyone else? Yes.
Pretty basic question. How does that affect like someone built what sort of application is out? What's the application gas?
So for the users, as I say, unfortunately, if you don't use like the loaded technique, it's more gas expensive. And then you should like estimate how big is your main functions. Like let's say if your deposit function is really big, like 200K, then maybe you don't care about 5K overhead. It's like nothing. But I've seen some protocols which had like really small functions, like just like claim my rewards, right? Like small function. But because it has overhead, it made it more expensive for users. But what is more important that you should like build your system from day zero, understanding do you need infinite size or not? Because there's nothing more ugly than like building that not infinite, and then you have to deploy extra contract, and they call each other, and in the end, it's the users who pay for that, right? So essentially, if you need really big protocol, you should go infinite size from day zero. In the end, it will be cheaper for the users. But if you don't need it, yeah, just don't use it. More questions? Not yet, but I'll post in my Twitter tomorrow. Oh, sorry.
Lo desconecto, espera. Espera. No, ahí está.
Yeah, it's pretty advanced topic. The reason I decided to skip in this format. You can get some ideas from synthetic hardhat package. It has some good explanations, but a quick answer is that it a bit depends on what you do, but the most gas efficient is there. You have these sorts of mixing functions which are shared between modules because essentially each module can access any part of the storage. And what you don't want to do, you don't want to call from one modular function of another modular through the whole like routing process because it's highly gas inefficient. What you want is you want to break your features in that way that it's kind of each module just like does its own thing. It doesn't really need to call other modules. But even if it does, it's better to use mixins where with some shared code, which allows like gas cheap access. Well, at least it's my position on this. Yeah, try to avoid it at all cost, yes. Oh, I see someone. Yes, please. Sorry? Yes, it's truly infinite because, again, all the mappings between signatures and implementations are on the storage, and Solidity storage is pretty big. You'll first run out of money than anything trying to fill it out.
I think he wants to know the exact number.
Yeah, I didn't do the math, but Solidity storage is pretty big. Yeah, well, to be super nerdy precise, no, it's not truly infinite. It's only as big as the Solidity storage. Yeah. All right, if no more questions, thank you everyone for coming. It was super lovely.
Música, música maestro.
Hey, nice to meet you. What's your name?
I'm from Spain.
Yeah, I've been to Spain many times. Great country.
Amazing. Do you like?
Yeah, I love it.
Ah, amazing.
Yeah, thank you so much, man.
Aquí a qué hora sigue la próxima. A las 2:30. Sí, las 2. Sí, soy yo. Le quita el feedback. ¿Qué haces acá? Es que quería probar la señal. Ah, pero ¿dejaste de grabar? Sí, ya. Ya dejó de grabar, pero se está retroalimentando re feo. A este sí tiene audio. Y otra vez todo. Hola. Pero estaba grabando desde acá. ¿Por qué? Porque se oye ese audio, weón. Está llegando. Ay, marica. Hola. ¿Tienes algo abierto? ¿Tenemos algo abierto? No. Está chistoso. Ya pues. Pero es lo que viene de acá, ¿no?
Está grabando desde acá, pero
Está grabando el ambiente.
el audio que está grabando es el audio de ambiente. I'm your volunteer, so if you guys need something else, let me know. Tell me. I'm just saying like I'm volunteer.
Él es de, ¿quién?
I'm just saying like I'm volunteer.
¿Quién es Nora? Nora, es de Nora. Adelante, confía. These guys have any issues, if they need anything, they will tell you.
Yeah, so that's what I wanted to say. Yeah, like we need something.
Exactly.
They didn't show up or practice.
These guys are gonna take care of it.
Let's go. Yeah. Good job. See you tomorrow.
Sí, pero esto tiene micrófono. ¿Dónde tiene el micrófono? No, no es ahí. Aquí ya lo miramos. Lo chistoso es que también cuando le doy cuarta me entra, mira. Ey. Recogiste el conductor de allá,
Sí, es de ambiente, güey. No, el convertidor está allá.
¿qué será?
¿Puedo preguntarle, Nana? Sí. Igual tú estás grabando, ¿sí o no?
Sí,
Pues en últimas decirle que le pasamos el material que tú tienes grabado.
Pero es que el
Está quedando con el audio, o sea, este audio, muteate allá la salida, la que estaba muteando.
no, acá, acá.
Hola.
Dale acá.
Okay. Buenas tardes. Good afternoon. Hello, everybody. Welcome to Building Blockchain Products for UNICEF, How to Get Involved. My name is Shane O'Connor, and I am an innovation manager with UNICEF's Office of Innovation, which is based in Stockholm in Sweden. But I'm very happy to be here at Devcon with you guys. Probably a lot of you know UNICEF as an organization, you've heard of us, you know what we do. Maybe it's not so clear exactly why and how we work with blockchain and technologies in general. So UNICEF's mandate is really to advocate for children's rights, to try and make sure that they achieve the best outcomes, and make sure that their health, education, protection is maximized across the world. And UNICEF operates in about 190 countries around the world. But UNICEF also has an Office of Innovation. And within that Office of Innovation, we have a ventures team, and we have a special team called Giga, and we'll be hearing from them in a little while. Go to the next slide. So actually, UNICEF has been working with blockchain looking at blockchain since about 2014, 2015. And UNICEF is one of the larger UN organizations, so big, bureaucratic, sometimes slow to move. So it takes us a long time to try and get UNICEF to move in this type of space, and to get us up to speed on how to properly use the technology that's out there in the real world to support UNICEF's programming. My own team that I work with, the Venture Fund, we have been providing kind of seed funding to support what we call frontier technology solutions that benefit children and the world. And we have some people from a few of the companies that have benefited from that here in the room today. But really from the slide there, you'll see we're looking at the intersection of the needs of 1 billion people and $100 billion industries. So we look at AI, drones, 3D printing, machine learning, and also blockchain and cryptocurrency. We've actually gone through 3 rounds of blockchain funding cohorts. We did our first cohort in about 2018, which was more of a kind of a thematic call for submissions. And you'll see that we had submissions from supply chain solutions, digital certificates and badges, impact investing. We did a second cohort back in 2020, which was more focused on financial inclusion, and that kind of particular, not so thematic, but more focused. And some of the kind of products, platforms, and companies that came into that cohort were focused on humanitarian cash transfers, remittances, and decentralized decision-making tools. We have a cohort that is about to be announced in the next 1 month or so. And this is some of our third cohort around blockchain. And you can see some of the kind of solutions and companies that have been involved there. And yeah, I think hopefully people can see those coming out pretty soon. Next one. This is really exciting, and Sana is going to be giving a talk later on at about 5:40 on the crypto fund, so I won't take too much of her thunder here. But in 2019, UNICEF launched a crypto fund. And we were, in fact, the first UN agency to be able to receive, hold, and disperse cryptocurrencies. So this is a big, big thing for the UN, and certainly a big, big thing for UNICEF. And this has really been able to help us to build digital solutions, and particularly digital public goods, to help us ensure kind of equitable access to these technologies and these tools to really try and support human development, obviously through the lens of UNICEF's focus, UNICEF's mandate on supporting children. One of the new applications, again, new for UNICEF, new for UN, in using blockchain is cash-based transfers, both kind of in a development context, supporting social protection schemes, but also possibly more interesting in humanitarian situations, so responding to disasters, trying to get funds out to communities who've been affected. We're actually at the moment looking at blockchain for cash transfer, and we're in fact, I don't know if they're here in the room yet, but we do have another cohort graduate that is supporting us, Rumsan from Nepal. But using blockchain for cash transfer to really increase transparency of these processes. So everyone can see the movement of the funds all the way to the beneficiary. And this is interesting for us as a UN agency, but also particularly interesting, I think, to donors too. And of course, saving costs compared to the traditional aspects for this this particular space. UNICEF is also looking, currently we're using blockchain to support the cash transfer programming. It's not cryptocurrency at the moment. It does get converted to fiat, but we are hopefully looking at using pure crypto cash transfers early in 2023, I think is what we're looking at. Yeah, next slide. So now we're on to Project Giga. So I'll introduce my colleague here, Gerben.
Thanks, Shane. So my name is Gerben. I lead the blockchain work for Giga at UNICEF. Giga is kind of like operates as a little startup within the Office of Innovation at UNICEF. We started in 2019, and we're sort of a joint venture between UNICEF and the ITU, the International Telecommunications Union. And our goal is to connect all the world's schools to the internet by the year 2030. So we have quite a lot of work to do. And we operate along sort of three pillars of work. The first pillar is mapping. Believe it or not, we actually don't know where all the schools in the world are. So we're using machine learning algorithms to analyze satellite data and identify schools and actually help governments find all the schools in their country. So that's always an interesting conversation with the Ministry of Education. The second pillar is about financing. So we estimate that it's going to cost approximately $428 billion to connect all the world schools to the internet, which is quite a lot of money. So we're really investigating like innovative financing models to find sustainable ways to make this happen. So there's two types of expenses that we have to solve for. The first one is obviously sort of capital expenses, you know, putting fiber in the ground, putting towers up, that sort of thing. But the second is, you know, once you connect a school, you have to pay for ongoing internet connectivity. You all sort of have subscriptions to that. That's kind of like how it works. You have to pay your bills, otherwise you get disconnected. So we've got a team sort of focusing on making that happen. And the third pillar is about actually connecting. So we operate a team called the Accelerate team, where we work with governments to investigate different kinds of business models for different kinds of scenarios. You know, schools in urban areas need a different solution than schools in super rural areas. So we work with governments to try to figure that out and advise them on sort of the best way to go, so that they at some point can take over the financing and the rollout of these programs and do it sustainably. So like I said, we launched in 2019. Our goal is to connect all the world schools by 2030. So far, we were joined by 19 countries. We have connected 5,300 schools. We've mapped about 1.1 million out of an estimated 6.5. So there's still like quite a lot of work to do. And we were super happy to be joined by 14 partners that support us, including Ericsson, Dubai Cares, Musk Foundation. Dell recently joined, which is a really big deal. And we've raised about $210 million towards this goal. So as you can see, we're still quite far off from the 428 billion required. So I'm going to talk also today a little bit about some of the projects and the products that we're developing at Giga. So the first one is what we call Giga Accounts, which is like a accounting platform and a sort of monitoring platform for the people who are actually controlling the money to pay for school internet connectivity. So the way it usually happens is that a country government or a UNICEF country office will write out a contract for like 100 schools or 1,000 schools in a country and have very little tools to be able to actually monitor whether this internet service is delivered. So what we're developing is a way for them to make it super easy to monitor that. So we have our own sort of real-time data application that schools can install on their networks, and reports data back to us, so that if data is subpar or connections get disconnected, we can actually hold internet service providers accountable. So that's our thing. And where we're hoping to go with this is right now the tool is really sort of to support these people in their work. But what would be really cool is to actually connect this with smart contracts and monitor whether internet quality is delivered, and if it is, automatically pay internet service providers. So that becomes super easy for people to connect schools and to get paid for that. The second product we're working on is called connectivity credits. It's kind of similar to the carbon credit market. So we're building a global marketplace for connectivity to make the connection of schools sort of more equitable. So what's currently the case in the free market is that schools in rural areas get connected and the ones in urban areas don't. Or if you're a school in the rainforest, an internet service provider isn't gonna like lay a fiber optics cable there. So what we're doing is we're providing a marketplace where we put tokens on these difficult to connect schools and allow internet service providers to redeem these tokens for benefits from the government, like for example tax breaks or special deals when bidding for spectrum bandwidth and that sort of thing. So that's currently in progress in Botswana, and we're looking for other countries to implement this in. Another area that we're investigating is NFTs. So we've launched in the beginning of this year the largest, I can say the largest sort of collection within the UN for this, called Patchwork Kingdoms. It's based on all the school data that we have. So for these 1.1 million mapped schools that we have, we worked with a data data analytics artist, to create these 1,000 unique art pieces and raise funds for Giga. So we sold all of them, raised about $700,000 US for that, which is really cool. And looking to sort of build upon that with our follow-up collection, currently title in progress called NFT2, where we're basically looking to build the world's most comprehensive decentralized database of school data. So the idea would be to create an NFT for every single school in the world, give this NFT to the schools themselves to own, and give them the ability, together with their communities, to edit the data for their school, keep it up to date, and own this data themselves. So right now it's sort of on our cloud server in Frankfurt, sort of locked up and for us to use. But it'd be really cool if schools own their own data. So that's where we're hoping to go with that. So we're looking to use NFTs as a sort of a portal into making that happen. And the last project that we're actually really keen to talk about at this event, it's like we're finally allowed to talk about this in public, which is really cool, is a staking experiment that we've been running in Rwanda. So we've been working with the Ethereum Foundation and the government of Rwanda to create an impact investing product using Ethereum staking to pay for school connectivity. So that's currently live, and we'll also be talking about that more in the panel discussion on Thursday, if people are interested. I think that's it, and then I'll hand over. There's one more. So, I mean, Rome wasn't built in a day, and these products aren't either. We're still, iterating on these. So we're asking you guys, do you want to help us build? So Antonio Guterres, mentioned us at the previous sort of General Assembly. So there's really sort of been a global call now for governments to step up and help with this cause. Now I'll introduce you to my colleague Naroa Surututha.
Thanks, Herben. Cool. To finish with the talk before we go into breaking sessions is that we cannot do this alone. We are relatively or fairly small team compared to all the things that we do and all the products that we are building. So we work with companies, with people on different ways. One is that we have a tech team, an internal tech team of product managers, data scientists, software developers, and we are continuously sourcing for that. So if you are interested in joining our team, keep an eye in our website because we have different jobs that go out there. At the moment, we have one for a blockchain developer that's open. I think it's going to be open for another week or so. So if either you are interested, you know anyone that might be interested, please spread the word. There will be another one for a blockchain product manager role as well that will be coming out soon, and others will keep coming out. So definitely keep an eye on that and apply. We also, especially for blockchain work, because many of the things that Herben was presenting are so new and they are experiments and prototypes that we are building, we work with external companies and with vendors to build them. And then we take them and we scale them internally, but we first work with companies to build them. So again, if you are a company that's working in the blockchain space, either on the NFT space, staking, tokens, and others, and you are interested in working with us, there will be again few calls for companies to apply to help us build the things that Herben was presenting. So there will be one call to help us build this NFT2 that doesn't have a name yet. So we'll be working with a company to build that. The same for the accounting platform that he presented, Kik Accounts. We have a working prototype at the moment. We'll again be looking for a company to help us build the next version of that and test it, pilot it in a couple of countries. So again, if you are in that space of smart contracts, etc., feel free to apply. And then the last one that will also shortly be coming out, it's on the connectivity credits. We are building that at the moment in Botswana, but looking to pilot it in a couple of other countries. So there will be another call looking for companies to build that token marketplace for connectivity. And then, yeah, I think those are the main calls that will be coming out. Of course, then we also work with companies as partners. So not so much contracting them, but we work with companies like Dell, the Musk Fund. Well, that's not a company, but the Musk Foundation, Ericsson, IHS Towers as partners, where these companies give in-kind contributions, either funding, monetary, but also sometimes they give us tech support, either through their developers, through their team. So again, if you're interested in helping out, reach out to us. And then finally, the last one is the venture fund. So if you are a startup in the blockchain space, there are continuous calls that are coming out for that. There will be one that will go out soon around climate tech solutions. So if, again, you are building something on that, 20th of October, it's coming out. So again, that will be out, and it's an investment of $100,000, more or less. With that, I would also encourage you to check this QR code so that you can register. Like that, we can also keep you in the loop. And if we have something that we also think that might be relevant to you, we can keep you in our network and reach out to you. Yeah, I think that's it. Yeah. Yeah, so for the rest of the time, we'll be standing each of us in one of the corners, so you can come to us if you have any follow-up questions, and we'll answer them, and we'll tell you more about the work that we do. Thanks.
Just know that it's right. It's one in a lifetime. For the first time in my life, I'm right on the edge now. I'm looking down. No matter how hard I try, can feel the ground. I'm on the edge now, taking the lead, taking a chance. You just touch me when I fall for you. All I need from you, my angels, to listen to your heart. 'Cause all I need from you, my angels, to touch me when I fall for you. All I need from you, my angels, to listen to your heart. I'll give it all I've got. I'm losing control tonight, but I hope you'll do us right. I'm right on the edge now, I'm looking down. No matter how hard I try, can see the ground. I'm on the edge now, taking the lead, taking a chance. 'Cause my angels touch me when I fall for you. All I need from you, my angels, to listen to your heart. 'Cause all I need from you, my angels, to touch me when I fall for you. All I need from you, my angels, to listen to your heart.
So, hi everyone. I'm Jesus Ligero, and he's Carlos. And we will make a introduction to Circom 2.0. So, what we will do in this workshop basically will be a very quick overview on what is Circom about, and then we make a little project that interacts with Hermes. Hermes was our we currently are working on the ZKVM of Polygon, but before that we were working on the rollup that was basically a ZK rollup that you can only transfer tokens and Ether. So basically what we will do is like we'll introduce you this project, this zero knowledge project that was done in Circom, and then we make a little project interacting with Hermes. Basically, well, you will see. Basically, you prove that if you made more than 10 transactions in Hermes, you will get an NFT, and all of this is proven by Circom. And basically, it's the project that we will explain to introduce you. So let's start. So, on a high-level overview, as you can see, this is so good. Basically, what Circom about, it's like a DSL is a domain-specific language for building zero-knowledge proof, right? So basically, what you want is like you have some kind of model or some kind of problem that you want to solve. You want to express this in arithmetic constraints. That is what will be the job of the Circom, for sure. Then using some tools, that in our case is the Snarks.js, you will convert these arithmetic constraints in polynomial identities that at the end you will have a cryptographic proving system. That is what you want. At the end you want to have some input and some witness, create some proof, and then have some kind of verifier in Ethereum, right? And with a proof and an input, see that the verifier is able to accept or reject the proof. So as I said before, as you see here, like Circom will be a domain-specific language, and basically will be when you have some kind of model, you write this model of this problem in a Circom language. That will be the DSL description, and then with the Circom compiler, you will get the arithmetic constraints. That later on, you can do it the verifying system, and we see before. So for a quick example, I don't know if you see any zero knowledge stuff, but it's always the Fibonacci example. So once again, we have the multiplicative one. So it's like the same as Fibonacci, but the numbers, instead of summing, you multiply them. Basically, well, it's the series of Fibonacci. So as we see here, we see a little example. Basically, I will explain a little bit what's happening here. Here we have a template that's how do you define a circuit in Circom, one template. Then you have inputs as signals. And by default, the signals are private. If you don't define it afterwards, you will see this better in the example that we did. And we have an output that by default is public. Basically, what it does is circuit is like computing the Fibonacci multiplicative and put it all the values in the EM, that is intermediate signal, as you see in the line 7. And at the end, we like assert, we put a constraint that one of the values of this multiplicative Fibonacci series is put it on the output signal. And bottom up, we see that we define a component main. Basically, how it works, Circom, is you can create like multiple templates. We see this afterwards, but you can create like multiple templates. That, let's say there are little circuits that you can connect them all together in order to make it more modular. And at the end, you have to have a main component that starts that is where the input will start, right? That will connect with the circuits that you defined before. So as a simple how to use Circom, basically you have to write a Circom circuit as we seen before. First you compile it and you can see the constraints and whatever. Once you compile it, you have the circuit compiled and the R1 CS constraint, that is what we see before, that are the arithmetization of the circuit. That is what we needed for make a prover afterwards. Then you can generate the witness once you compile the circuit, that basically are all the intermediate values that you need for afterwards create a proof, and basically is what we see here in the schema. Well, this is, I will get this very quickly. As I say before, Circom is a very modular language. You can create like templates as we see before, and you can intercorrect templates. So this is very useful. For example, we have templates for verifying a Merkle proof, and you can just use it like connecting with the Merkle proof and use it the output for verifying things, right? So it's easy to audit and easy to write larger circuits. And this is like a full schema of everything. Let's see how it starts. So, well, I say before, you have a Circom program, you compile it, and you have the constraint system. Then what you will need, let's go to here. You will need a verification key and a proving key. In order to do this, you need like to do, I don't know if you know, but you need to do some kind of trusted ceremony. Depending on if you are using one proving system or another, Grot16 or Plonk, you need to do a trusted ceremony for every circuit in case of Grot16, or in case of Plonk, you have one universal one universal ceremony that is multi-party computation. The point is you have some kind of computations to create a trust. You have like some distributed computation to create a proving key and a verification key, and this is what will have basically the verifier and the prover. And down here we can see that we have an input, and with the Circom and a circuit compiled, and with this we can create the witness that basically is all the intermediate signals, and basically with this we can end up creating a proof. Sorry, because it's a lot of doing things, but I think with an example will be more clear, maybe. And this is the state of the art and how the DSL language like Circom are going around. As you see, Circom is one of the most used right now. And now Carlos will explain a little bit how Hermes works and how it works. Yes.
By the way, there is a tool that you can use. It's a web app that you can use in order to play around a little bit with Circom. So you don't need to install anything. You just go enter and then coding your circumcision, it compiles, so you can play around with it a little bit. Okay, so what we're going to do is a circuit in order to prove that a certain account has made more than 10 transactions in the Hermet rollup. Okay, for that purpose, at the very beginning, I want to explain a little bit what is the Hermet ZK rollup circuit. Probably you will already know that, but basically a rollup works like you make a transaction in layer 2. Okay, so there is a coordinator that gets all these transactions. It aggregates all these transactions in a batch, and from this batch, the coordinator is the entity that gets all the transactions. It accumulated transactions, and basically it makes proofs that verifies the correctness of these transactions in one single layer 1 transaction. Okay, this is why it is called rollup, basically. Now I will focus a little bit on the Merkle tree that we use and the parameters that are inside in the state tree. So it will be very useful for later on in order to code the circuit that we're going to code. Okay, first of all, this is just a schema of all the circuits that are involved in the Hermet rollup. As you can see, there are a lot of them. You can check the repository in order to see all the Circom language, that all the work that has been done over there. We will focus here in the last one, which is the hash state. And this is how the state tree looks like. As you can see, when the account that we add into the state tree, it has different parameters. One of them is, of course, the Ethereum address. The second one is the baby chap. You have a balance, you have a token ID, and you have a nonce. Okay, this is very important. And how you compute the hash of the state. Okay, so basically when you add a leaf into the Merkle tree, you need a key value. So the key is an index which will be enforced by the smart contract, and it will be incrementally, okay, in order to not have a lot of levels in the Merkle tree. And we need also the state, the value. So we need to hash the state. In order to hash the state, so basically we just hash with Poseidon 4 field elements. The first field element contains the token ID, the nonce, and the sign. You can notice here that the token ID has 32 bits, the nonce has 40 bits, and the sign has 1 bit. The second element is the balance. The third element is a coordinate of the baby chap, and the fourth element is the Ethereum address. I think it's worth to mention that I showed previously the baby chap here is divided into the sign and the Y coordinate. Okay. Okay, so you already know how to hash the state of the Hermet rollup. So what we are going to do now is to get hands a little bit dirty. So we are just going to code the circuit from scratch. It's a small circuit, not so difficult. So let's grab your computers and let's code a little bit. Okay, perfect. Could you hear me well? Nice. Okay, so let's start. So basically, I will create a file, okay, that I will name it Devcon workshop.circom. So the first thing to do is to specify which version of Circom are we going to use. Yeah, okay. Yeah, it's better like this? More? Yeah, okay, nice. So what we're going to do now, so in that case, we are just taking the token ID, the nonce, and the sign. We are building the element 0, and then we are putting the balance into the element 1. We're putting the Y coordinate into the element 2. We are putting the Ethereum address into the element 3. We are performing a Poseidon hash, and at the very end, in return, what we will have, we will have the value. Okay, and this value will be inserted in the SMT verifier. Okay, so first thing to do, what we want to assure now. So we need to assure that this account has been done more than 10 transactions. Okay, in order to do that, we are going to set up a variable over here, and we are going to define a component. I will name it min-nonce, for example. We'll choose the greater than. We will comparing all possible bits between them. And this component, you can check the component by, as I did right now, just by opening the hash state component and see what is going on inside. You can do the same, entering in the circumlink, in circuits, in comparators, and seeing which are the inputs and the outputs of the greater than. So, but those are quite simple, I would say, because there is just two inputs. Okay, and one output. Okay, so basically we are comparing the nonce and the min-nonce. Okay, and the output, basically, you can reference it as out. And here we are just setting a constraint. So this is like a very important constraint for this circuit, because it basically assures that the nonce that you will be used in the SMT verifier indeed needs to be more than 10. Okay, so now what we're going to do is to use the template of the SMT verifier. But before that, we need to hash the state. So what we're going to do first is to reference another component, which is this one. It's the hash state. Here, perfect. Wait, sorry. Perfect. So, and this component, you may see that the inputs are token ID, nonce, sign, balance, Ethereum address, and the Y coordinate. So basically, what I'm doing here, okay, I'm just setting up all the inputs that I declare at the very beginning of the circuit. I'm just inserting them, okay, into the component. And the output, will be the value of the state. Okay, so here comes the nonce, here comes the sign, here comes the balance, here comes the AY, and here comes the Ethereum address. Okay, so now we have the value of the state. So perfect. So what we're going to do now is to prove, with the SMT verifier, as I mentioned before, we are just providing the root, providing the siblings, providing the index, providing the value, and this component basically will verify that the siblings provided and the value corresponds to that root. Okay. As I mentioned previously, I have done this circuit before. I don't remember all the SMT verifier inputs and outputs, so I will just copy paste. The other ones are a little bit easier than this one, but this one is a little bit tricky. But well, basically, Here I'm declaring the SMT verify component with n11 plus 1. There is a signal which is enabled, which is basically the constraint will be, I mean, it's equal or 0. Sorry, there is an input signal which is enabled in order to use the SMT verifier. The functionality, the SMT verifier has different functionalities, which could be adding a leaf, deleting a leaf, updating a leaf. So in that case, if we put a 0 here, it will be basically no, this is the SMT processor, sorry. So regarding the SMT verifier, the 0 is just verifying that, as I said previously, the root will match all the siblings. So here is the root, which is the public entry that I declared at the very beginning of the circuit. We are setting up here all the siblings, okay? These two signals, no, sorry, these three signals are not used for this circuit, so we are just setting to 0. And this is very important, the key and the value of the Merkle tree. So basically, the key will be the index, and the value will be the hash of the state, okay, that I calculate over here, okay. Now I notice that I just renaming this component to hash state. Okay. Ether address, you mean? Okay, thank you. Line, which line did you say?
38.
38.
No, it's okay. No?
That's it.
Good. Thank you.
I think it's good. Yeah, thank you. So that's it. We have a circuit. We code it in, I don't know, 15 minutes. That basically proves that a certain account belongs to the state tree and assures that this account has been done more than 10 transactions. Okay, simple as that. I mean, it's a super small circuit. Okay, and it's very easy to code it. I mean, of course, you need to check the components that you are using, the comparators. The SMT verifier probably is the most complex one, but it's not that hard. It's super easy, and everyone can read it. That's also the beauty of Thiricom. Okay. So what we are going to explain now basically is what to do now, no, with this circuit. Basically, what we're going to explain, Jesus is going to explain it. Basically, what we're going to do is to generate all the trusted setup, and we're going to generate the verifier. We're going to see the smart contracts, and we're going to perform some tests in order to see that everything works fine. Yeah.
Okay. So maybe okay. I will get away from this. Okay. So well, basically what we will doing now, like now that we already have a circuit, the first thing that we have to do is like compile the circuit, and maybe I should run the script. Well, it will take a while, but maybe I could run it until we explain, right? So basically what we are doing here is like executing all of these commands with basically with the exec-sync. If you are more interested into details, you can check in the circom.20 documentation. Basically, we're following this. What we are doing here is basically first compiling the circuit. And then when we have the constraints, what we need now is, I don't know if you remember before in the schema, but we need you need a verification key, right? We need a proving key, a verification key, in order to make the proving system. So in order to do that, basically what we are doing here is like a multi-party computation that we mock it ourselves, because well, this is not a serious project. This is just a workshop project, but this should be like decentralized. This will be done in a multi-party computation, but in this case, we just do it ourselves, right? So basically what it's having here is like we create a new powers of tau, we have some entropy that it's Carlos Jesus, then we prepare the phase 2, and then we make another contribution, and basically at the end we end up with a key that basically is the verification key that we need. With this key, we can generate the verifier of the solidity, and also we can generate the proofs to send to the smart contract, right? So basically, all of this is just for getting the compiled circuit and the key. So I don't know how much it will take. Like it will take that long, but I don't think it's like it's good to just to wait. I will continue explain it. At the end, you end up with this key. With one file is a key and one file is the compiled circuit, and with this you can like do whatever you want, right? Like create export the verifier that is this contract that is created automatically, and then basically you can like start interacting with this. Once we run the script that it will take so long, and we get the verifier, what we can do now. So remember that in our circuit, let's find the circuit. This one, right? We have 3 public inputs. So we have the root, right? The index, and the Ether address. So somehow we must to check this with the smart contract. Now we will see the smart contract and see how we interact with this. But basically, as you see, we have 3 inputs, right? So the verifier, as we can see, basically there's some internal functions, and basically what the only function that we want is like the verify proof, right? This basically verify proof is a function that we check from input the proofs and public input, and we return either true if the proof goes well or false if the proof wasn't, right? So as we see, the array of input as 3 because we have 3 public inputs: the root, the index, and the Ethereum address. So let's build a smart contract to get around with this. So I don't know if you are like you know a lot of Solidity law. I will make like just a quick overview, and that's it. Basically, we are like presenting everybody that wants to interact with this NFT. So I'm using the OpenZeppelin NFT library. Basically, that's it. And
don't you need at least one private input?
Don't you need at least one private input? But yes, but the private inputs are not in the let's say are not in the input. When you see input in the verifier you are talking about the Solidity verifier contract, right? When you see the input, you only pass there the public inputs.
I'm talking about the circuit in general. If all the inputs are public, then anyone can generate the proof.
Regarding the circuit, all the signals
So
just coded as by default private.
Yeah, let's get back to maybe.
In Circom 2.0, when you define the main component, there you are defining the public.
Which are the
rest of the ones are private.
So in the smart contract, you only pass it the public ones. Yes. Okay. Go. So okay. So basically, it will be an NFT. I use the NFT library, and what is important here is, like we said before, we need a snapshot of the Hermes, so an Hermes Merkle root, an address of the verifier in order to call the verify function, and a nullifier in order to not let people to take like 100 NFTs with the same proof, right? So basically is what I'm setting here. The constructor basically set the RC721 with the parameter that token name, token symbol, and we set the root and the ZK verifier. And then we have like all the function that is important, that is the climb Hermes NFT, that basically what it checks is you pass as an input an index and the proof that you want to, and the proof of the zero knowledge. Basically it checks if you already claim it, and then it calls the verifier, which this is the contract verifier that we see before, with the proof, and this is the public input. As we see, we have the Merkle root, the index that you want, that we want, and the message sender. This is done because like to not that you cannot claim like another NFT that you do not own, right? This is how you secure that only the message sender can claim his own NFTs. And basically this will call the verifier. If all goes good, the proof will be resulting correct, and the nullifier will be set to true, and you will get your NFT. So you do have questions about this or someone? Okay.
ZK verifier, it's
Yes, the ZK, good question. The ZK verifier is this one, is the verifier that it's created automatically by Circom. Like when you deploy this kind of systems, you always deploy this contract that basically is like a library, right? That it just verify a proof, and then you create a contract that that interacts with it, right? In this case, you verify the proof, and if it's correct, means you are NFT. Okay. So in order to do a flow, we do a test. And I think I will get a pretty, that is not this one, is this one, that I will do a very quick overview. Basically, what we are doing is like using our Hermes library, so maybe it gets a little bit confusing, but anyway, I will explain, I will do a quick overview, and I think you will understand. So first we create 3 accounts, basically. And then there's a function that creates a new state that basically what we are doing is like creating the Merkle root, right? Creating this state that we want to check against. So what we are doing here is like creating 2 accounts and then doing trend transactions from account 1 to account 2. Basically, we do this because remember that we need that the nodes of any account is 10 or more in order to be able to generate a valid proof and claim the NFT. So somehow we managed to create the state with the 10 with these accounts, and one of them will have like nonce 10, so we can claim the NFT. So afterwards, basically what we are doing, well, this is a hard hat test. I don't know if you're familiar with, but basically we are deploying the verifier and then deploy the ZK airdrop. That is the contract that we made. And then basically this is the, then we start the test, and basically this is the input, right? As we see here, we have a lot of inputs. Some of them will be private and some of them will be public and will be checked against the smart contract, right? So we create an input and we create the Snark.js library that basically is the library that allows us to create the proofs. And basically we pass an input and the directory of the circuit compiled, that is this one, and the directory of the verification key, that is this one. And with this, we are able to generate the proof. And with the proof, we are able to basically connect the user that has this address and be able to claim the NFT with the following proof. And I can run the test. It should work. No, tú no tienes esto. Well, this I will run all the tests. Maybe it's well, I don't know if you has been able to test, sorry. Being able to like download the take the repo or download the repo, but and well, since here, right? Since here we got the demo. Yep. So this basically will be it. You can check the repository. If you have any questions, don't hesitate, and that's it. Que es una hora. So,
Yep. When I have the DAOs and the other
the power of DAO ceremony.
Yeah. Can that be used, for instance, I wanted to create my secret.
Yeah.
Can I use the same DAO?
So as I say before, well, at the end of the talk, like depending on the proving system that you're using, if you use Plonk, you can reuse the ceremony. If you use Groth 16, you have to like one of the part of the ceremony is like you have to do it for every circuit. You have to. So in this case, because we use Groth 16, we have to like make a multi-party computation for every circuit.
Is a repository available online?
It should in the presentation. I'm sorry if you don't get it. Here. Aha. Yeah, maybe we could start with that, right? It will help.
Thank you.
Thank you. Sorry. We have more than one more slide.
Thank you slide.
Yeah, we have a thank you slide. Sorry. So you? No? It was not a question. So that's it. So thank you so much, guys.
Thank you.
Pues ya está.
Don't worry, let's just explain a little bit. So, what is Circle?
Ay, perdón.
Nice. It's working.
Not so loud.
I hope everyone hears me. So, hola, and welcome to our workshop about running the Beacon Chain Explorer on your own. We will go through how we came to the idea to make the Beacon Chain Explorer, and then we will explain how you can actually run the Beacon Chain Explorer. This is Stefan, my colleague, and me, Patrick. We both work for the company Bitfly. So yeah, first Stefan will introduce you to our company and how we actually came to the idea to make an Explorer for the next stage of the Ethereum project. Then we go briefly through the architecture of the project, and finally we will show how you can run the Explorer on your own. But before we start with anything, everyone who wants to participate, like interactively, we need you. Sorry, I was on the wrong laptop. Yeah. We will go first through how we came to do the Beacon Chain Explorer, and what the architecture of the project looks like, and finally we will show you how you run the Explorer. But before we go to anything, we need you, anyone who wants to participate, we need you to download a few things. So, are there anyone who wants to participate on his laptop? Do we have installed Docker and Docker Compose?
If you don't.
If you don't, it's like a one-liner. Yeah, and you need to clone this repository. This is not public. No.
Then check it. Sonst mal. Yeah. So can you basically try and see if you can access the repository, if we made it public or not? Yeah, then we'll jump back to that, and I'll quickly introduce kind of who we are a bit more in detail. So the company Bitfly was founded in 2017, and we've done a range of products. We've been basically active since the beginning of Ethereum in the space. We actually created one of the first block explorers, but kind of let it slack a bit. So that was etherchain.org. It's one of the older ones. And then later on, we kind of regretted not putting more effort into that explorer. And then we kind of decided now that there's going to be Ethereum 2.0 or
basically the merge, we decided to create another explorer specifically for phase 0. And that explorer kind of ended up being the beacon chain explorer, and it started out where everyone could basically see all the information about the beacon chain. Maybe a show of hands who has used the explorer before, maybe just to kind of get a feel. So about half of the people have used the explorer before. So maybe if you want to, a show of hands who's running a validator. Okay, quite a few of the people that are using it. So basically, we wanted to create a nice place for you to understand what's actually going on with the validator, to see the different states of the validator, to kind of make sure you don't get slashed. And we also operated one of the bigger mining pools called ethermine.org that was now retired since the merge, and we kind of shifted away from mining a bit and we're focusing a bit more on staking. So kind of to chill a bit our other products, we have staking.ethermine.org now, where you can stake with less than 32 ETH, and we have ETH pool. If you're too lazy to run your own validator, you can just upload your validator key, and we'll kind of take care of that for you. And then a brief history, I kind of already touched on that. So it started out in 2019, end of 2019, with the first test networks. So even before the genesis of the beacon chain, here you can see a small or kind of nice picture of the genesis event. We kind of created like a slot view. So each one of those rows, if you don't know, is an epoch, and in one epoch there are 32 slots, and here you can kind of see the green part is when it was proposed, the red one is when it's missed, and the yellow is if it's orphaned. And that's kind of a nice overview of the first few epochs when the genesis happened. And we also have like a checklist below how much finalization we have, no, participation we have, and if the epoch is justified and finalized. And a nice rocket for like the countdown when Genesis started, which is also pretty nice. So that's kind of how this whole project began, and it kind of exploded a bit more and more. And with the merge, we tried to add more information, not just the phase 0 information, and it kind of grew and grew. And this presentation will also be kind of about how we kind of handled the scale, and we'll also give a kind of a workshop where you can help us with kind of finding ways to scale better. Yeah, so let's go a bit to the architecture. So in the beginning, this is kind of a very simple view what the Beacon Chain Explorer looked like. I also presented this, a similar slide, I think it was ETHCC a year ago, where we had just the Prism node, we had Infura node, and the Infura node was mainly to get the deposit data from ETH1. And then we had an exporter that just basically wrote everything into a Postgres database, and that worked really well in the beginning. It was really easy to work on. And then we just had a Golang front end with some templates that kind of served everything to the end user. And even when I presented it back then, we kind of can see that Prism already needed like 67 gigabytes of data, Aragon node already 1.4 terabytes, and Postgres already 2 terabytes of data. And then I looked at these numbers again, how it's running today, and kind of a reason why we had to scale a bit more. So the numbers now are that we switched to Lighthouse, and we have a 32 slot sync. So there's different kind of sync versions that you can choose, and depending on what amount of slots you choose, the more information is stored, but the quicker you can retrieve information. And we basically want to store everything. And that's already a 5 terabyte disk that you need for that Lighthouse. Then Aragon is 2.1, and our Postgres database is huge. So kind of the tables and the indexes that we have in the Postgres database, they just don't scale that well. So it's already 10 terabytes big, and we don't only run the mainnet, we also run the testnet, and the testnet is just that amount and even a bit more for different testnets. So it's a huge amount of data, and it's getting a bit expensive running that in the cloud. So we're going to talk about how we kind of started migrating away from that. And basically the scaling challenges during the merge. So this is kind of a analytics view that we had. So we had concurrent sessions of 2,267 people that were looking during the merge, because we had like this nice slot view that you saw before, where people could see, okay, during the transition what was happening. It's a nice visual way of kind of tracking it. And we had a lot of people, we were kind of prepared. So you have this Super Mario mushroom that should power you up, but that mushroom was kind of overpowered by the people looking at it because the way the architecture was designed, it just didn't scale well. We have front-end instances that kind of have to query the same stuff. Like if we have 5 front-end instances, they do 5 times the same queries because we don't just have like one layer that updates our cache. We just have every front-end instance that has its own cache. So these are things we kind of try to improve. And then again, we have very expensive indexing as well in Bigtable and Bigtable. That's what we're going to get to later in Postgres. And Postgres also has to get a lot of the table into memory to be able to query stuff, which is a lot of the times not very efficient, especially with huge amount of data. So what we try to do is we started out with one big binary where everything runs, and we try to strip away things from that big binary and kind of isolate that in microservices that not every binary does everything. And if we duplicate one binary, we don't do unnecessary work. And kind of the migration is kind of a bit challenging for us because then we have to kind of make sure that we manage a lot of the technical depth that we kind of have and are maybe adding through changing technologies. So maybe we can jump back to the beginning of the, does it work now?
Yeah, it works now.
Here? Okay, maybe you want to
Yeah,
just,
the repository should be public now.
yeah. Could someone maybe say if they can access the repository? Yeah.
Yeah, there's a Docker file and a Docker Compose file in it. And if you just run Docker Compose pull, it will pull all the images. And when we later get to the interactive part, everything will be done. We have all the things ready.
Perfekt. Ja, soll ich weitermachen dann? Das ist ein Dings. No, back, ja. Oder mal, ja, mache ich. Okay, great. I hope the internet is good. Let's pray a bit because when we tried it or tested it before, it took a while. So here you can see I kind of touched on that, the scaling and large tables. So in Postgres, in the beginning, we didn't have any partitioning at all. So later on, when So guys, if you wanna submit something, I guess 5 minutes to draw something up. Otherwise, we're gonna continue. Ja, ich weiß nicht, ob jemand das macht hat.
Wir können das präsentieren wollen.
Nee.
Wir nehmen eine
Wunderbar,
Funktion
ne?
mal vor und lesen es vor.
Ja, ja, passt. Ja, sonst ist es aber jetzt mein Laptop, oder?
Das ist dein Laptop.
Ja.
Jetzt kommt dann erst das Slide mit.
Wie lange haben wir?
Es ist 54. Wir haben nur 20 Minuten.
Okay, ja, dann machen wir es weiter. Ja. Ja. Ja, dann machen wir weiter und sagen wir das mal, wenn ihr am Ende präsentieren will, kann da jemand am Ende präsentieren. Ja. Ja, magst du das jetzt dann machen?
Ja, ich kann das machen.
Ja, mach das meine präsentieren kann.
Ja, lass ein bisschen reden.
Oder frag einfach, wie man präsentieren mag. Frag einfach, wie man präsentieren.
So I think everyone is finished now. Someone is still writing. Gib mir noch Zeit.
Ja.
Das macht absolut keiner mit. Das Internet nicht gibt.
Also das, doch, die machen Internet war ganz okay.
Ah, das funktioniert bei denen?
Ja, keine Ahnung. Ja.
Weil bei den zwei, das Internet gar nicht funktioniert.
Ich glaube, er wird vielleicht sehen, was der steht.
Ah ja, die wollen präsentieren, ja.
Ja gut. Ja.
Ja, wenn die dann alle so diskutieren und schreiben.
So viel Zeit haben wir jetzt nicht mehr.
Ja.
Wann
ist draußen 20?
Ja. Ja, mach das einfach mal weiter.
Ich meine, so lange dauert das Aufgeben von den Dingen dann auch nicht.
Ja.
Ich was zu sagen.
Das mal einfach weitermachen. Jemand präsentiert und sonst
So if anyone is ready and wants to present in front, you can do it, or we gather the papers and just read it. Geh schon durch.
You guys want to present? Yeah, let's go. Let's go for it.
Yeah, I'll ask for backup from the team. But
it's perfect.
Lots of assumptions here.
Yeah, it's gonna be fine.
Okay. Should we present general?
You can just maybe hold. I can hold it up,
There
and
you
you
go.
can maybe go.
Okay. Again, lots of assumptions that we made without knowing too much of the spec or your specific use case. But let's go. So cloud first, I think still makes sense, especially for like DOS or whatever you guys might need that for. In terms of front end, I don't know if this is a bottleneck, but we mentioned thought about clustering or some auto scale for this, or even if we're going to the Web3 ethos of let's put this on IPFS or like distribute it somehow and really make it undeniable service, scaling that way, or it could be just some auto scaling service, some Cloud Run or GCP or whatever we might use for that. So I don't think this would be the bottleneck anyways, the front end itself. I think that, and if depending on what you have here, this could be heavily statically generated, so it might be something that you wouldn't be a problem. Then second layer, we're talking about cache. So I imagine most people our team imagines that most people are looking at past data. So you probably don't have to have direct access to the database. You don't have to do like real queries against it. You probably cache heavily previous data that was already from previous blocks that will never change. So things that could be like pretty much frozen there because it's not, it's really static and stale data, let's call it like that. So this, depending, I guess there are probably lots of ways of doing this cache layer. This could be like a DB level. This could be some like Redis cache level or something like that. But yeah, really something before the database itself. Then on database, our friend, I forgot his name, but our friend there gave an idea of maybe we could start sharding this. Maybe some sharding based on transaction hash or something like that, which same thing. Since this is mostly data that will live forever and not touch it again, we probably have a part that's only read-only. So it's there. Very high output for reads, not that much in terms of writes, and a part which will be the right part, which this part here would have more direct access to the actual nodes. And then the nodes probably would make sense to have multiple archive nodes if the RPC calls might be a problem. I don't know if it makes sense to have like, lots of different machines running those instead of Infura. Infura for us in our company is always a problem. Infura and Alchemy, or if there's anyone from these companies, talk to me please. But yeah, maybe just run your own archive nodes for these. Not sure also if the actual RPC calls are a bottleneck for you guys.
Necessarily not, but it's good to have a backup.
Okay, so
Yeah.
at least maybe to like archive nodes you
Yeah.
guys are going to run for that. And then this part here would just be like the heavy write part, which everything that you check as a new, you would just update the database based on that.
Thanks so much.
Okay.
Thanks for participating. I'm gonna hang that up. Okay, magst du weitermachen?
So this is the solution we came up with. So we switched.
Kind of the solution we have right now.
Yeah, this is the solution we have right now.
Kind of.
We switched parts of the data set. We now store in Bigtable instead of in Postgres. So we thought like it's not really necessary to have a relational database for this kind of data set, and Bigtable scales really well. So I think like we were able to index all of the current EAT1 transactions in 5 hours. So it's like really, it scales really well, Bigtable. So we now store the blocks, the balances of the validators, every transaction, all of the attestations in Bigtable. And this resulted in a really much more stable index time. So now you can see it takes us like really stable 30 seconds to export all the data of one epoch. Yeah, and this is where we come to the interactive part of this workshop. For everyone who wants to participate, I think it's like 2 or maybe 3. Yeah. Noch eins größer.
So he's just resetting everything he's done to kind of start fresh with you guys.
So the first thing we want to do is to initialize the databases. So we turn on Postgres where it is in Bigtable and initialize the Postgres tables and the Bigtable what is it called tables database. So the next thing we want to do is to start a EAT1 indexer. We called it that because we're not really creative, but it indexes like it first gets the blocks from the execution client and encodes it in protobuf and stores it into Bigtable, encoded in protobuf, and then we index after that we index the blocks with all the fields and values and the transaction as well. So one big thing is like we're actually not using Bigtable from Google Cloud. We are using Bigtable emulator from the company Bitly. It just emulates the Bigtable API and stores it in SQLite database. And I think like for just storing and then analyzing the data, it works well. It's not like it will not scale for 1,000 requests per second, but for analyzing the data, it's like a really good solution in our opinion. So the thing here is we are not able to to reach the nodes we synced before the workshop in the cloud. Somehow we don't get access via this Wi-Fi. So we are now running the nodes on our laptops, and that is where you see some errors because the nodes are not synced and it's not like doesn't work well. But ja, die App funktioniert. Ist die gleiche. So now we have the databases and the 8.1 index are running. The next thing we want to run is the exporter. The exporter is like just the exporter we had before the merge, but now it will index the blocks from the big table that we just exported in the 8.1 indexer. Again, we have some errors because the nodes are not synced. The next thing is like the statistics module. And this is also a really important and integral part of the whole project because the indexer will aggregate the data of one day and store the aggregated data of the one beacon chain day in the database, and so all the queries become much faster. And the last thing we start is the front end. It will get started with the cache updater and the front end itself, which is a Golang web server, which just queries all the databases. So all the things are running now, and we can browse the Beacon Chain Explorer on localhost 8080. The thing is, since the nodes are not synced, it will take some time until any data will show up. There's one there's some extra scripts we wrote into the main script. The thing is, like we understand like this repository not as we want to make it the Beacon Chain Explorer available for everyone who wants to explore the Beacon Chain. Not so you don't have to trust us by going to beaconchain.org, beacon.in, beacon.in. You can run it yourself. It will take some time until it's like synced, and we will try to make it more easy. But the thing is, we really what is it saying? We stand by the decision to make this Explorer open source. So it's not we will try to make it available for everyone. It's not like we made the decision to go into Bigtable from Google and to run it in GCP just to make the scaling issue like gone. But that doesn't mean it's not available for everyone. Thanks to such amazing open source project like from Bitly, the GCP emulator. So the last script is now you have like a Postgres database where you can tinker with the data. We made just some the script is not up to date. But now it is. Yeah, okay. Okay.
You have to restart so up to date. Restart the services.
I don't know if I want to do that.
But has anyone followed along?
Is anyone following along? Is it working? Or? Okay, it's working. Yeah.
Have you tried the explore block command as well?
Yeah. Okay. Yeah. So the thing is, like with this repository, we show really how you can set up the Explorer, and we know it's not like there's a lot of technical debt that is like we need to solve it, but it's working for everyone, not just for those who have really GCP accounts and everything. I think we can go to the next slide. Yes. Also, das ist schon der Schluss.
Das ist probably, ja. Soll ich das machen?
Ja, mach mal.
Okay, so for anyone using our mobile app or the website, we've got a discount code Bogotá 50 if you want to use it. You can get our premium app services. If you have a lot of validators, it's nice, among other things. Or if you want to use our API services, you can use the code over the website, not directly over the mobile. And yeah, if you're running a validator, the mobile, and you don't know about the mobile app, it's pretty nice. It lets you look at your validators on the go. It lets you get notifications when you propose a block, and kind of see if you've gotten those 30 ETH block reward or something like that. Yeah. Okay, then.
That's a lot of features.
Yeah. If you want to contribute, here's kind of the overview of kind of the resources. So we have a Gitcoin grant that's linked below. You can tweet at Beacon Chain if you see any issues or something. Create issues on the GitHub repository that's also linked there. And oh, did anyone still want to take a picture? Or no? Thanks. Yeah, that's basically it from us. Thanks so much for participating and listening. If you have any questions, maybe? Yeah. Yours right now that you Sepolia it's called. So it's one of the test nets. It's a bit smaller, so it should be able to sync in a reasonable amount of time. The Wi-Fi isn't the best here, so here it could take a while. But it's a lot smaller than Prata, or which is Girly, or Mainnet, which are pretty huge right now. Okay. Any other questions? Yeah. Not sure if I if I should answer that, but it's quite a lot. It's quite a lot. So it's what is it? 5 figures? Yeah. Do you have a or?
I just want to ask you the construction of time series database. Did you look at other time series databases? We looked especially at ScyllaDB.
Patrick.
We looked at ScyllaDB especially, but we looked also at other DBs. But in the end, we took something that also fits in our team. Like we don't have so much resources. Also like takes so much man hours to get into a new technology. And for us, this looked like the best fit. And right now we are really happy with it. So
Yeah, we basically went from an export time of 30 plus seconds for attestation assignments to like 5 seconds, which is a lot better. And there was less contention between different queries on Bigtable now that we moved, but that can change if we have everything on Bigtable. We're just starting to migrate, so I hope it stays good.
yeah, and layer 2 is coming. So
okay. Anything else? Then thank you very much for listening and for participating again.
yes, thank you so much. Okay.